In this video, we are going to discuss dot product of vectors in a plane, and we will see some applications of it. The definition is as follows. The dot product of two vectors A and B given like this is defined as the sum of products of its x coordinates and y coordinates. So please look at the notation. It is A dot B. That's how we read it. And we just multiply the x values first and add them to the product of y values. So let's see an example. So if we are given two vectors A and B, as in this example, A is -3 to 5, B is 2 to 1, we can find the dot product to be A dot B, which is equal to, well, let's first substitute the values, -3 to 5 dot, let's make a big dot, 2 to 1. Well, this is -3 times 2, which is -6, and plus 5 times 1, which is 5. So it gives us -1. So what we find in dot product is a scalar value, as in here, it is -1. It is not a vector that we find, it is a scalar, a number as a result of the dot product. Related to the dot products, we have orthogonal vectors. Two vectors are called to be orthogonal if, and only if, the dot product results in 0. In other words, if we find the dot product of two vectors to be 0, then this means on the coordinate plane, the angle between these two vectors is 90 degrees, or we can say these two vectors are perpendicular. So we use orthogonal in vectors. So two vectors are orthogonal if they are perpendicular, or meaning if their dot product is 0. Let's see an example. Here the question says, find the dot product of U and V, and then determine if U and V are orthogonal. I mean, check if the product is equal to 0 or not. So, let's calculate the dot product. Well, U dot V will be 3 to 6 dot -4 to 2. So it will be, let's show, 3 times -4, which will give me -12, plus, I will go with the y value, 6 times 2, which is also 12. So I have -12 plus 12, which gives me the result to be 0. So we can say that these two vectors, U and V, are orthogonal. Let's see another example. Again, we are given two vectors, so let's calculate the dot product to be 2 to 5 dot 8 to 4. So it will be 2 times 8, which is 16, and 5 times 4, which is 20, so it will be 16 plus 20, which will give me 36, which is not 0 for sure. So we are going to say U and V are not orthogonal. So the angle between them is not 90 degrees. So we are going to see in another video how to find the angle between two vectors if they are not 90 degrees. So if the dot product is 0, then the vectors in the dot product are said to be orthogonal, perpendicular, or the angle between them is 90 degrees. If the dot product is different from 0, then they are not orthogonal. If we look at the properties of dot products, we see that it is like a normal multiplication operation. Well, we can change the place of the vectors and the result does not change. We can just distribute one of the vectors into the other vectors like this. We can multiply the dot product here with a scalar. When we multiply a vector, when we have dot product of a vector with 0, we get 0. And here we have a relation between dot products and the magnitude of a vector. So according to that, if we have the dot product of a vector by itself, we find the square of the magnitude. So let's see an example regarding this last property. Keeping our property here, let's see what we can do if we have this kind of a question. It says, use the dot product to find the magnitude of a, which is equal to minus 5 to 12. Well, what we're going to do is, if the square of the magnitude is equal to the dot product of this vector by itself, so considering a, I can, before substitution, I can go like this. If I take the square root of both sides, then square and square root will cancel, so I will have the magnitude to be the square root of the dot product of this vector by itself. So when it comes to practice, let's substitute the vector a into this formula. So we will say the magnitude of a will be the square root of, minus 5 to 12 dot minus 5 to 12. So when we do that, we will get the following. It will be minus 5 times minus 5, which will give me 25, plus 12 times 12, which will give me 144. So actually, this will be the square root of 169, which will end up with 13. On the other hand, remembering that we find the magnitude of a from the component form as the square of the coordinates, minus 5 squared plus 12 squared. Well, actually, we also get here 25 plus 144, as in this step, see, they are the same. So actually, that's the relation between the dot product and the magnitude. So we go through the same steps after all when we go through the magnitude from the formula. So they are the same. That's what I want to mention here. Let's look at this problem. The vector u gives the numbers of men's basketballs and women's basketballs respectively in stock at a sporting goods store. The vector v gives the prices in dollars of the two types of basketballs respectively. Fine. So the first vector gives us the number of basketballs, and the second vector gives us the prices respectively. Now, respectively means, the first number here, $27.5, refer to 406 men's basketballs, and $15 for 297 women's basketballs. All right, that's what it means respectively. So, in part A, it says find the dot product of u and v. So, we are going to write u dot v to be, 406 and 297 dot $27.5 to $15. Okay. When we do the calculation, we have 406 multiplied by 27.5, which is 11,165, plus 297 multiplied by 15, which gives us 4,400. 455. Now when we add these up, we conclude a number of 15,620. Now this is part A. We find the dot product. Now in part B, we will discuss what we have found. What is this number? We multiply the number of basketballs with the number of, with the prices in dollars. So when I multiply a number of something with its price, I find the total price. So this actually is the total price for men's basketball. It's the total price. And this number is the total price for women's basketball. So when I add these total prices, I find the number of, say, a grand total that this store can make at most, because, I mean, these are the numbers of basketballs they have in stock. If they sell all of them, this is the amount that they are going to get or earn. So we can say that 15,620 is the grand total. Actually, it's the dollar. We can put this unit here. It's the grand total, which means that's all the money they can make or earn from the sale of basketballs. Now is your turn. Please solve these questions and enter your answers in the answer sheet.